Alrighty guys, welcome back to another tutorial, and now that we have the basic registration logic built out, what we can do now is we can start listening to the blockchain for transactions sent to our bot account, aka deposits or payments, whatever you want to call them. Basically coins sent to our bot account. And remember, like we said, the first time they are going to send coins, it's because they are trying to register their account. In other words, link their blockchain account to their Discord account. Now, after they are registered, they can continue to send coins. And this is going to be, we're just going to have it update a balance on their user object. But you can have it where, maybe they're buying like digital gold or buying in-game items, whatever you want to do. That part is kind of up to the developer. But either way, what we are going to be doing is listening for those payments from our bank that we already have set up in like the first or second tutorial. And before we get into more of the technical details or any of the code, I want to walk you guys through this deposit object because this is what we're going to be storing in Mongo. So the first thing, of course, like every Mongo object, this is going to have an ID. In this ID, we're going to get from the bank's transactions. The bank already creates a unique ID for each transaction, and we'll be taking a closer look at that later on, but that's what this is. Now the amount, of course, you can probably guess this. This is just the amount of coins the user is sending to our account. And the block ID, this is a little bit more technical. It's pretty much the unique ID of the block as it's stored on the blockchain, and we'll see how this comes in handy in just a bit. Now, confirmation checks is related to this right here. So by default, whenever a user first sends a payment to the New Boston blockchain network, that payment is not confirmed. It's just like an attempted payment, or they're trying to pay someone. Now, that is why whenever our bot first receives these deposits, it's going to set is confirmed equal to false. This means that yes, we see the payment out there, but it doesn't have any confirmations yet, meaning it didn't officially get added to the blockchain or it wasn't verified yet, basically. Now, this confirmation checks, if you remember, this is going to say, okay, once we receive this payment, how many times are we going to hit the network and say, hey, is this verified yet? Is this verified yet? Is this verified yet? So we are going to do that up to 20 times because this process is actually going to have a 5-second delay. So this should really never take longer than like 2 checks. So 2 checks means like there was 10 seconds, and that means that like the network was acting slow. But we're just going to put 20 as max just to be super safe. And the memo, of course, as you guys saw, this is just the description that they add in the transaction. And for ours, that's what that random code generated is going to be. Now afterwards, when they're already registered and they're just sending payments, it doesn't really matter what they type in the memo. The memo we are just using for the registration process, but they can type whatever. Now another thing that I want to mention, and I saw some users talking about this pattern in the community, is that instead of this registration process, yada yada, you can actually have this memo be linked to something directly, like a digital item or in-game currency or whatever. And then technically users don't even have to register. So you can just have people like, it's almost like a unique UPC or an item code where users can just pay for those things directly. But we get some other benefits with registering as well. So anyways, going to continue along. Just want to point that out in case you guys have any cool ideas. The sender, of course, is the sender's account number, and this is our basic deposit structure. So what we are going to be doing in our code is we're going to be running more or less 2 processes. The first process is going to listen for these deposits, and then the second process is going to say, okay, what deposits did we receive that are not confirmed yet and have less than 20 confirmation checks? And that process is independently going to go look at confirmations, and once a payment is confirmed, then we process their payment or update their balance. All right, so the last technical thing I want to point out to avoid any confusion is this right here. So whenever a user from their client right here, they go ahead and send coins, What this is going to do is it's going to send an entire block. Now, the block from a network protocol point of view, it includes all your transactions, which of course include the amount, the recipient, any optional memo, if it's a fee, or if it's just a regular transaction, so on and so forth. The block contains a lot of information. A lot of this is just kind of specific to the network protocol. It involves like signatures to make sure that no one can, cheat and pretend to be your account, so on and so forth. So why am I saying all this instead of coding in Discord? Well, I say this because what we are doing is we are connected to the bank. Now, what the bank does to make it easier for the user to actually store and query this data is it takes these transactions out of the block and it stores those as a separate object called bank transactions. So you can think of a bank transaction is really all the user specific information in the block that isn't part of the network protocol that only the users are really going to care about. Now, to show you guys what this object looks like whenever it's stored, I'm actually at the bank transactions endpoint that we're going to hit in just a second. And you can see that within each transaction, it's either a fee for the primary validator or the bank. Now, typically a bank transaction looks like this without any fee, and it just has an ID, and this is what we're going to be storing as our ID. And then of course it has an amount, a memo, the recipient, and so this is of course the recipient, which is going to be our bot account. Now, there are a lot of other transactions going to be happening on the network, but we only want to make sure that we are looking at the transactions that were sent to our bot account. I really don't care if user A sent user B some coins for pizza or whatever. And another thing is it has a reference to its block, or in other words, its parent or its container. Now, why am I saying all this again? Because of this. Even though we are going to be looking at bank transactions right here, those bank transactions came from a block. Now, it's the block itself which has confirmations on it. So again, even though we're going to be looking at the bank transactions and essentially converting those to deposits, pulled open the wrong thing, deposits right here that we're going to be storing in Mongo, the deposits are not going to have confirmations themselves. In order to check if these deposits are confirmed, we're going to need to look at the block, and then we're going to have to say, does the block have any confirmations on it? If the block itself is confirmed, then all transactions, aka deposits, within are also confirmed. So that's why we need to follow this two-step process. We just can't say, okay, if you have some transactions right here without any confirmations, then we can just accept the payment. No, we need the confirmation, and this says, yes, this payment is valid. Okay, so hopefully I have that pounded in your head hard enough. So now let's go ahead and get to the code. So the first thing I want to do is I want to update this on already, because I want to call a function after here that is going to pull the blockchain. Now, actually can make that right here. So we'll say it's going to be async task in, if I can spell async def blockchain. Okay, so this is gonna actually be the parent function that calls two other functions, and we'll say it's gonna pull the blockchain for new transactions or deposits. Now, another thing is that why am I doing this? So these are called bank transactions. We're going to be looking at an endpoint called bank transactions. Why did I decide to rename it to deposit in our architecture? It seems like I'm just making things more confusing. Well, whenever I think of a transaction, especially like at my bank, for example, I'm thinking that I can send someone something, and that's a transaction, and also that I can receive something, and then that's a transaction as well. Now, for this system, it's basically just going to be like a payment integration where you can receive funds, but we don't have a withdrawal system built or anything like that. So I want to make it very clear that these are just deposits. These are just payments coming in to our bot account, and then we're going to sell some service or digital good or whatever. But either way, I I just think it was a little bit more clear looking at everything. So anyways, we're going to say poll the blockchain for new transactions, aka deposits, sent to the bot account, which is the account that we own. Now, I'm going to leave another note here. You guys hear that ding? What the heck was that? And I'll say only accept confirm transactions. Okay, so here we go. This is going to be my poll blockchain, and it's going to do these two things. And I'm going to break this up into two different functions that we're going to write later on. One is going to be called check deposits, and the other one is going to be called check confirmations. What is this? Get out of here. Check confirmations. And you guys can probably tell what these are going to do. This one is going to look for, keep pulling this open. This one is going to query this endpoint and see if there are any new deposits or any new payments that someone tried to send to our bot account. And then this one, I don't have the endpoint ready, but it's basically going to check for those confirmations. So for now, let me just comment those out and write pass so my IDE doesn't freak out. And all right. Now, another thing that I want to do is I actually want to poll this blockchain, not just once, where as soon as my bot starts up, then I'm just going to poll it and say, okay, that's it. You checked once and you don't have to check anymore. This needs to run again and again and again. Now, I just don't want to run it as fast as it possibly can, like on a while loop, because then it's going to unnecessarily hit the network and it's going to say, do you have any new transactions? Do you have any new transactions? So I think that was a little much. So instead, I'm going to put it on a 5-second loop. Now, anytime you want to make a command in Discord that needs to run these periodic tasks, it's actually really easy. You don't have to set up Celery. You don't have to set up any cron job or Linux task in the background. They actually make it a piece of cake. So in where you import commands from discord.ext, import something called tasks as well. And then go back to right above poll blockchain. And then what we're going to add is a decorator, and that is tasks. We're going to run this on a loop. And then for seconds, we're just going to say 5. So this means, and I'll put 5.0 just to make it very clear. So this function right here is going to run every 5 seconds. Now, it just doesn't run right off the bat because we still didn't call it from anywhere yet or invoke it. So we have to do that from our onReady command. So in order to run this function as a task, what we need to do is we need to call poll blockchain, but instead of just running it just like this, we actually need to call start on it. So again, anytime you want to run a periodic task, then you can just make this decorator, and then you can call the function name and then dot start. And just to show you guys that this is working, I'm going to say, we'll just say I'm going to print out apples every 5 seconds. And this is just purely to test that this is indeed running as a periodic task. So in our console, we should see ready, apples. If I could zoom in, apples, and let's just do it one more time, even though I think we get the point right now. Apples, there you go. So we did indeed set up our function to run on a 5-second delay or a 5-second interval. So now let's go ahead and create this check deposits function. So let's go ahead and delete this print apples. I don't think we need that anymore. And I'll uncomment check deposits. And of course, we don't have it created yet, so we need to go ahead and do that. So I'm going to make a function called check deposits. And what is this going to do? All right, so what it's going to do is it's going to fetch bank transactions from, we'll say from the bank, and then we'll insert new deposits into database. All right, beautiful, beautiful, beautiful. So let's pop back open our, why is Chrome only open like half the time? Okay, so we're gonna be using this endpoint, bank transactions. Now let me just go ahead and copy this. And all right, so what we can actually do, if I pop that open one more time, is this. So whenever we call this endpoint right here, which is just our bank's IP / bank transactions, what it returns is not only all of these results, but it returns some metadata too. And this says, if you have a next page, in other words, if there are more results, because this page, it only sends back 50 results at a time. So either way, if you have more results that are not shown on this page or this result set, then it's going to come back with a link to next right here. Now, if we don't have any link to next, then it's going to be null, just like this. This one doesn't have a previous page because we are on the very first page. So either way, I say this because whenever we are checking for new transactions, then we can add a filter to say, instead of all the bank transactions, which are the transactions to and from everyone, we want to filter this down where we are only looking at the bank transactions for our bot. And also, whenever we order these, we want to start with the newest ones first. So with that filter, and we're going to be writing that in just a second, what we can do is we can basically iterate through until next equals null. That means we got to the end of the result set in that we don't have any more results to check. All right, so let me go ahead and, I can copy this right here. It doesn't really matter. So what I'm going to do is I am going to make a variable called next URL. And this is going to be the very first URL that we query. And again, once we are done querying this first URL, then if it does have a next page for us to view right here, then that is going to be stored in next URL. So even though it technically is the first URL right now, it makes more sense in just a bit. So I'm going to make an F string. And the first thing I want to do is replace some of these with my constants. So we already stored the bank IP. And did I import these? Nope. So from config settings, I'm going to import bank IP. And what do we need? Bank protocol. And also that bot account number. Okay. Man, kind of annoying how it always bumps it back. Okay. So bank IP first. So I'm going to replace this section with the bank IP. I'm going to replace this section with the bank protocol. And then what we can do is this. Okay. So the limit and offset we don't need. Instead, we are going to add a filter called recipient, because remember, if I pop this open again, in these bank transactions, they have a recipient key, and this means the person who is receiving the coins. So we don't care about this. We don't care about this. We only want to look at the transactions that are coming to our account. So we're going to say a filter on this where recipient equals bot account number, so only our transactions coming in. And another thing that I want to do is there's an ordering flag available, and this says how do you want to order these transactions whenever you get them from the API. And what we want to do is we want to order these by the block's created date. And when we do that, we pretty much just say, give us the most recent blocks, aka the most recent transactions first. Now, in order to do that with a nested field, you do block 2 underscores, and then you do created date. And just to make sure that you spell everything correctly, block underscore created date. So this is essentially going to give us the result set from the API of all of our new transactions coming to the bot account. And then what I'm going to do is I'm going to make a while loop, and I'm going to say, while you have a next URL, continue to fetch this data. Because whenever we get to the end, like I said, in that next URL is going to be null, then we just want to break out of our loop. We say, we fetched all the data that we have. All right, now in order to make this network request, what I'm actually going to be doing is making another utils, and I'm just going to call this network, and that we can say import requests. Let me bump this up. And all this is going to do, by the way, is it's going to use this request library to fetch an endpoint, fetch some API data, and then it's going to convert it back to Python. In other words, a Python dictionary, and it just cleans up a little bit of, the dirty work. So I'm just going to name it fetch. And then just so I enforce named arguments, we're just going to say what URL do you want to fetch from? Are there going to be any headers? I don't believe we're going to have any headers in this, but I always like to include it. And then we are just going to say send get request and all right. So send a get request and return the response is a Python object. And we'll just say the response is equal to the request dot get, and it takes URL, and the headers equal the headers that we pass in. So basically just taking whatever we call to fetch and just routing it to request.get to make sure it's a get request. And after that, we want to return this response. But before we do, we just want to go ahead and convert it to JSON. And that's going to give us a Python dict to work with. All right, so simple enough. And now if I go ahead and say from utils.network import fetch. Okay, beautiful. So now we got that fetch command. Now just to actually do this, so let me say print next URL. Okay. So this isn't the actual logic that we're going to have. However, what I do want to do is run this, and I did kick off. Okay, check the posits. So I just want to print out the URL because this is like the most laziest way to do it. But I just want to print out the URL. All right, so let me stop that, and I'm just going to copy this URL, and then we'll pop it back open. Okay. So I just want to throw it in my browser so we can take a little bit better look at the response that's coming back. So in this case, since I only had 5 transactions ever sent to this bot account, that's why we don't have a next page, because these pages, like I said, they either return 50 results at a time, I believe. But either way, let's just take a note of this response. So it comes back with the count that says how many total deposits have been sent to this bot account. Is there a next page that you have to check? No, there isn't. A previous page doesn't really matter for us because we're only parsing in one direction. And then we get our results right here. And these results are a list of bank transactions. Okay, so now we can get to actually parsing out this data. So let me scroll back up here and okay. So the first thing I want to do is say for all of that data that came back, even the metadata, what I want to do is call fetch, and the URL is going to be equal to the next URL. In other words, the very first time is just going to be equal to this endpoint that we're looking at right here. And that for the headers, this isn't going to take any special headers, but I did want to enforce the passing in of those, but you can just pass in an empty object just like this. So the next thing that I want to do is I want to take these results, which remember is just the list of bank transactions, and I just want to store it in a variable that is just a little bit more intuitive other than results. So I'm just going to call those bank transactions and set this equal to the data, which is all the data that we get back. In other words, this entire thing. So it's going to be equal to data results. So data results, just like that. Now after this, what I want to do is I want to update this next URL. So the URL is important whenever we're fetching data, but after we get the data, what I would like to do is set it equal to the next URL that needs queried. Now in this case, we don't have any more pages to query, so it's going to be null. And that's going to be an indication for our bot to say, hey, we don't have any more data to fetch. We can go ahead and break out of this loop now. So how do we do that? We can just say the next URL that we have to fetch is equal to whatever the response is in the next key. So this is either equal to, like I said, a URL or null. All right, so at the end of this loop right here, since this is going to be equal to null, that's why this loop is going to only iterate once, or in other words, it's only going to iterate the number of pages that you have to parse. So that's all this. And now what we want to do is this. So we took all those bank transactions, and remember, these bank transactions are now only for our bot account. If you see the recipient 5982, or what is it, 59842, all of these, since we threw in that query param, these are all for our bot. Oh, can't talk because I'm phlegming my throat. These are all for our bot accounts. So what we want to do is we want to go through each of these, all of the bank transactions, and we want to insert them into our deposits collection, which we actually don't even have yet. Let's go ahead and make that. And remember that this is going to be the shape of it right here. So let me actually go ahead and copy that, and I'll paste it right here just so we have a reference. Okay. And maybe I'll zoom out a little bit so you guys can see. And actually, let me know the text size on YouTube if this is too small, too big, whatever. But either way, what we are going to be doing is we are going to say for bank transaction in bank transactions. So iterate through all of our bank transactions one by one. And remember, we're going to start with the newest first. So what we can do is we can essentially just try to insert those into our collections one at a time. Now, since we are using the ID, which the bank gave us, if we are going to try to insert the same one that we already inserted, then it's going to throw an issue, because remember, in Mongo, this ID, it has to be unique. So I'll show you guys a cool little trick. Whenever we get one of these bank transactions right here, we can either look at the ID of it and we can say, does this ID already exist in your deposits collection? If so, then just skip it. If not, then go ahead and insert it. Now, think that through. Whenever you take that and you query the database and say, does this exist or not? That's one query. Now, whenever it says, no, it doesn't exist, and you say, okay, insert it again, that's another query. That's two queries. However, what you can do is you can just go ahead and try to insert it, and that's just going to take one query if everything's chill. Now, if that doesn't work because that transaction already exists, then the database is just going to send back an error anyways. But either way, it minimizes the amount of queries from 2 down to 1. Now, again, there's probably a more efficient way to do this, but I just want to talk you guys through the initial process. So anyways, what we are going to try to do is essentially insert one of these bank transactions. Now, another thing that I want to do is this. From PyMongo errors, there is an error called duplicate key error, and this is what we're going to be expecting if we try to insert a bank transaction and it already exists. In other words, maybe we just inserted it like 5 seconds ago or whatever. So in our case, whenever we receive one of these duplicate key errors, meaning, hey, these bank transactions, you already parsed these, you already insert them into Mongo, everything's good to go already. What we can do is just break out of this loop. So again, this while loop is going to continue fetching API data. It's going to continue pulling in bank transactions until one of two things happen. One, it runs out of pages to fetch, which means we just parse the entire bank database. Another thing is that whenever we get to a bank transaction that we already added, it's going to say, bro, you already added this. We're just going to break out of the loop now. And the reason that this works is because we are ordering from newest to oldest. Now, if we were iterating through the oldest ones first, then we would have some issues, but we're not. So that's why this entire system is going to work. Okay, so now instead of here, we actually need to insert those deposits. So we're going to say for each bank transaction, we're going to, in our deposits collection, insert 1. And then how do we need to insert it? Well, it depends on this info right here. So the ID of this is going to be equal to the bank transaction. In this ID, if you guys can see, it doesn't have an underscore. So that's what I'm doing right there. And I can probably copy this and nah, I won't be that lazy. Okay. So after ID, what do we need? We need the amount. So the amount on a bank transaction, how do we get that? Okay, it just looks like the amount. Beautiful. This is almost too easy. And all right, what do we need to add after this? The block ID. So the block ID, this is going to be equal to the bank transaction. And how do we get the block ID? So you need to look at the block dictionary and then the ID from that. So that you do block, and then for the block, you get the ID. All right, now after this, what do we need? Confirmation checks. So confirmation checks, we don't get this from the bank transaction API data. We are just gonna set this equal to 0 at first, because remember, what we're doing right now is we're just taking these bank transactions and pretty much just cloning those over to Mongo. We didn't check for any confirmations yet. We are not doing anything fancy, so we're just gonna set confirmation checks at 0. Is confirmed. This is the easy one. By default, is it confirmed? Well, I'm guessing if we never even check for confirmations yet, we probably cannot confirm that payment. So we're gonna be setting that to false by default. And for this memo, so the memo we're going to store is just whatever memo they had on that bank transaction, and that is going to be called memo. I don't know why I copied that, but there you go. Let me just copy this. All right. So it's just equal to the memo field. And last but not least, what do we have? Okay. So the last bit of information that we need to store is the sender. So we'll say that the sender, and how do we get the sender? So in the sender, we got to query the block again, and there's a key or an attribute in this block called sender. So we had similar structure up here, but instead of the block's ID, we're going to get the block sender. There we go. And believe it or not, this deposit logic should be complete. Did we fetch bank transactions from the bank? Yep, it looked like it. Did we insert new deposits into the database? Well, it looks like that, but let's just go ahead and test that now. So actually we can add for now. Okay. Let's just print out something like polling blockchain. Even though you may not want to do this if you are releasing this to production, because it just might clutter up your logs or whenever you try to debug stuff. However, just for testing, let's go ahead and run this. Okay, so ready, polling blockchain, and that's good. Now let's pop over in Mongo and see what we got going on. Gonna refresh this and check this out. Okay, so it looks like we now got some deposits in there, and yeah, it's looking pretty good. Displaying documents 1 of 5. So what it did is it essentially queried this endpoint, which was good. That's the one we were hoping it to query. And it took all those and it converted them to deposits, and it stored it in our deposits collection. So right now, even if I refresh, the confirmation checks remain at 0, and is confirmed is false, because even though it's aware of these incoming payments, since we don't have the confirmation logic built in, it can never confirm or process any of the user's payments. So that is not good, but everything else seems to be working. So in the next tutorial, what we can do is we can work on that deposit confirmation logic. I'm pumped up, so I'll see you guys then.